Hi, my name is Joseph, and I am the team captain of Team N-1, a team name that couples well with our team number, Team 19876. Our team is part of Tech Brick organization. However, all of our team members joined just this summer, making our team a rookie team. But despite this, we were able to build a robot that can drive both over and around the barrier, quickly score freight on either the team shipping hub or the shared shipping hub. It can quickly cap, and it can also spin the duck carousel, as well as having barcode detection with our high-scoring autonomous routine.
My name's David. Before we started building anything on our robot, we made a CAD of the entire thing to see where we could position our arm on our robot and also how high it would be. We wanted it to be able to fit within the 18-inch cube for starting position and also still be able to reach across the robot to intake freight and to also reach all the way up and cap and also score on the high goal.
Let me describe our overall field strategy. For the Alliance shipping hub, we drive along the wall, avoiding the barrier, and strafe over to score while simultaneously moving our arm. This is efficient since we don't rotate the robot, and it allows us to get a cycle time of 7 seconds. Our strategy is similar for the shared shipping hub. Also, we can go over the barrier if needed. This gives us a flexible strategy to cooperate with our Alliance partner.
Before we built anything else on our robot, we built our chassis. Our chassis was made 12 by 18, the 12 inches allowing it to go in between the barrier and the wall, and the 18 inches giving it stability. We created our chassis with a smooth underside so it could also go over the barrier, and we used Mecum wheels to give it a full holomonic motion. Our chassis also has its axles supported in 3 places so that it prevents any damage that could happen to them.
Hi, I'm David, and now we'll be talking about the arm. We have a great arm design that is very versatile. It can move 300 degrees in either direction from the starting position. We control yaw by a bevel gear that rotates the arm about a vertical axis. The motor is placed below the pivot to keep it out of the way. To control pitch, we use a worm gear system that drives a belt. The belts are used to absorb shock on gears and other components. We use the worm gear on the pitch to prevent backdriving the arm while carrying cargo.
We designed our intake this year to have a rotating hinge so that it could grab stuff of a lot of different sizes. Our intake can intake things, output things. We designed our intake in CAD so that we could 3D print it in PLA Plus so that it would be light and still strong at the same time.
Hi, I'm John. So we put bumpers on our robots to push freight away, which we actually need a lot because, well, we bump into it and we don't want it getting stuck under a robot. So we put wall wheels horizontally on the bumpers so we can glide along the wall, which we will use a lot.
We designed our TSC on CAD and 3D printed it so that it would follow these criteria. We wanted it to be easy to pick up with our intake and also would have stability, so we made it with a pointed top that other people could easily place their TSCs on top of.
I'm Dylan. I did the coding for the robot. Some features I added were field-centric driving, and I added automatic movements for the arm using encoders. I added barcode detection for autonomous, where it will use touch sensors to detect which location the TSC is on. In the best scoring routine for autonomous, we have barcode detection, and then after it scores that block, it scores a second block, and then after it scores that second block, it scores by going into the warehouse and parking.
So if you see our budget charts, you'll notice that our income is more than our expenses, which allowed us to dedicate some money into summer outreach events and off-season robotics training.
Outreach is one of the most important parts about FTC. This last summer, our team sent some students to Camp Quest, which is a summer camp for children near Baltimore. There, we taught them about STEM by making rockets and launching them at a nearby park. One of our sister teams brought their robot from a previous year, and we helped demonstrate it by letting the kids drive it around a little bit. We also sent some students to volunteer on an FTC qualifier in Laurel, Maryland. We helped queue teams and keep all the operations running smoothly. Also, since there's a shortage of robotics parts in America, we helped by sending a few of our extra pieces to other teams around America.